Hello and welcome to this video. In this video we're going to look at the first law of thermodynamics. So in the previous video we looked at the zeroth law, and the zeroth law defined the temperature of a system and how we can actually define formally what a temperature is. Now we need to look at the energy of a system, and we said briefly in the previous video that the energy of a system is dependent on the temperature. We're not going to go into that too much detail in this video. In this video, we're just going to look at an overview of how we can think of energy in a system. So the first law of thermodynamics is just a description of the energy of a system. And what we call this is the internal energy. Okay, so this is the energy held within a system, is known as the internal energy. Now the internal energy, as in all of the energy inside a system, the internal energy is only made up of two types of energy, okay? Only considerably made up of two types of energy. Obviously, there will be other types of energy present, but we can always say that the internal energy is just all of the kinetic energies of all the particles plus all the potential energies of all the particles. Okay, so the internal energy of a system, the total energy that a system holds, is just the sum of all the kinetic energy of the particles and all the potential energy of the particles. We're saying that if I have a system here that contains a certain amount of gas particles, let's say all of these dots are gas particles, we know they're always whizzing about because this is how gas moves. And we'll look at this idea of Brownian motion in a second video. But we have all of the kinetic energies based on all of their speeds, and then we have all of the potential energies based on the weak interactions between all of these things. They will all have electrons and nuclei and things, so they'll end up with some weak force of attraction. Anyone doing chemistry will be able to then recognize those kind of intermolecular forces. And so this is our kind of definition of internal energy. It's just the sum of all the kinetic energies and potential energies. But then something that would go further from this is to explain how would we change the internal energy of a system. Surely if we have just a box that has a set number of particles in, there should be ways that we can change the energy of a system. And so then if we go a little bit further, we're going to call the internal energy U, just as a symbol rather than writing out internal energy all the time. And the internal energy, or the change in the internal energy, could be described as the change in Q plus the work done on the system. Okay, so Q is the heat energy. So we can heat this thing up or we can cool it down. Doing one of those things will increase the kinetic energy of the particles. More specifically, it will also then increase the potential energies, since you're bringing things closer together because they're moving around much quicker. And the work done on the system is by compressing, so pushing them all together, or expanding, so pulling them all apart. And these two things, so the work done on the system means that I'm going to have to compress or expand that system, and we know work done is a unit of energy, so I will end up changing some amount of energy. And these two ways that we're going to change the amount of energy in a system is what we're going to now look at in the rest of these videos. We're going to first focus our energy on looking at the heat energy transfer and the types of heat energy transfers we can have, and then we'll look at the work done on the system, and then we'll see how those things can change. So the main things to take from this video is that the sum of the kinetic energies and the potential energies of each individual particle in a system will give you the total internal energy of the system, so we can quantify the total energy a system has, and we can only ever change that by heating up or cooling it down, or compressing or expanding it. And we'll see different ways in more of the work done videos
where we're going to look at more of how does the way we expand or contract it actually make a difference.
Thank you for watching.